Good morning, everyone. I am Mrs. Harshika AV, Assistant Professor in the Department of Artificial Intelligence and Data Science. Today, I am going to discuss subject code AL3451, subject name Machine Learning, which is prescribed under Regulation 21. Unit 4, Neural Network, especially Multi-Layer Perceptron. Multi-layer perceptron or MLP is one of the most widely used artificial neural network models. It consists of fully connected layers that transform the input data into output layers. The purpose of an MLP is to learn complex relationship between input features and output values. Structure of MLP. An MLP is called a multi-layer network because it contains three types of layers: the input layer, one or more hidden layer, and the output layer. This diagram illustrates the architecture of the multi-layer perceptron. On the left side, we have the input layer, which receives the input features. The hidden layer performs computation and extract patterns from the data. Finally, the output layer provides the prediction or classification result. Every neuron in one layer is connected to all neurons in the next layer, making it a final connected network. Input layer. The first layer of the new network is the input layer. Each neuron in this layer represents one input feature. For example, if we have three input variables, then the input layer will contain three neurons. The input layer simply transfers the data to the hidden layer without performing any computation. Next is hidden layer. Hidden layers are responsible for processing the information received from the input layer. An MLP can contain one or more hidden layers, and each layer can have multiple neurons. These layers help the network learn complex relationships and patterns present in the data. Next, output layer. The output layer generates the final prediction or result. In binary classification problems, there is usually one output neuron. In multi-class classification problems, the number of neurons corresponds to the number of classes. Thus, the output layer produces the final decision of the neural network. Working of multi-layer perceptron. The operation of an MLP consists of four important stages. These are forward propagation, loss function calculation, back propagation, and optimization. These steps are repeated many times during training to improve the accuracy of the network. Forward propagation. Forward propagation is the process in which information moves from the input layer to the output layer. Each neuron receives inputs from the previous layer and computes a weighted sum. The result is then passed through an activation function. This process continues until the final output is generated. Weighted sum. The neurons computes the weighted sum of the inputs. Formula Z equal to summation I equal to 1 to n, where Wixi plus B, where Xi is input feature, Wi is weight, and B is bias. Activation function. Activation function introduce non-linearity into the network. Without activation function, neural networks would behave like simple linear models. Common activation functions include sigmoid, ReLU, and tan. These functions help the network learn complex patterns, where sigmoid activation function produce output between 0 and 1. Because of this property, it is commonly used in binary classification problem. The output can be interpreted as a probability. Formula sigma of z equal to 1 divided by 1 plus e power minus z. Next, ReLU. It stands for rectified linear unit. Its output 0 for negative values and return the same value for positive inputs. ReLU is computationally efficient and helps solve the vanishing gradient problems in deep neural networks. Formula f of z equal to max of 0, comma z. Next one, tan H activation function produce output values ranging from -1 to +1. Since it is centered around 0, it often performs better than the sigmoid function and helps the network coverage faster. Next, loss function. After generating predictions, the network compares them with the actual target values. The difference between predicted and actual values is measured using a loss function. The objectives of training is to minimize this loss function. Next one is back propagation. Back propagation is the learning mechanism of neural networks. It calculates the error at the output layer and propagates it backward through the network. This process allows the network to adjust its weights and biases to reduce the error. Gradient calculation. The gradients of loss functions with respect to each weight and bias are calculated using the chain rule of calculus. The gradient indicate how much each parameter contributes to the error. Next, error propagation. After computing the gradient, the error is propagated between from the output layer to the hidden layers. This enables every neuron in the network to update its parameters and improve performance. Gradient descent. Gradient descent is an optimization technique used to minimize the loss function. The weights are updated in the direction opposite to the gradient so that the error gradually decreases after every iteration. Next, optimization. Optimization algorithms are responsible for improving the learning process. They iteratively refine the weights and biases so that the neural network covers toward the best possible solution. Under that, sophisticated gradient descent, it is also called SGD, updates a weight using one sample or a small batch of samples at a time. It requires less memory and often coverage faster compared to traditional gradient descent. Last one is ADAM optimizer. ADAM, which stands for Adaptive Movement Estimation, is one of the most popular optimization algorithm in deep learning. It contains momentum and adaptive learning rates to achieve faster and more efficient training. Thank you.